great to see you here. In the previous videos, we were talking about different applications about probability. In this video, I will be talking about the application of a Monte Carlo simulation on a project. My name is Luc de Koster, founder of the Koster Academy. And before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the Monte Carlo simulation. The Monte Carlo simulation is, in fact, a simulation technique in which the conditions are simulated many times. So we have a kind of simulation, a typical simulation that we would give you one outcome, but with the Monte Carlo simulation, we repeat the testing. We get a large number of simulations, a large number of calculations, and it provides a probability distribution of possible outcomes. Now, Monte Carlo comes from the roulette game. We know the roulette game. We've been talking about it before. The roulette game basically is a typical random generator where we have numbers generated between 0, 00, 000, and 36 at the roulette game itself. So basically, every number has the same probability, and that's the definition of a random generator. Now what we're going to do, we're going to build a model, different activities, and every activity has a specific probability profile. And each time we have a random number, that random number will, in fact, relate to a duration or a cost of that specific element. We can use it in weighting lines, we can use it in a lot of applications, and of course we can use it in project management. In project management, we have a precedence diagram. And here we have the relationship, the precedence relationship between different activities, and we can identify different paths through the network. Now, the variables that we typically have relate to the cost or the duration of the task, and there is a specific probability profile. We can give to any of the activities a probability distribution that corresponds with the characteristics of that activity. And when we have the specialized software, it's possible to define those different probability distributions. And based on the probability distributions together with the generated random numbers, for every activity we will have a duration or a cost. We start from random variables and we determine the duration of the cost, and at the end we find the total duration of the project. And here it's different from the PERT method, because in the PERT method or the 3-point method we were going to look at typically the critical path, and we only had one path basically that was the result, the critical path. In a Monte Carlo simulation, all paths can become critical. We are not going to identify the critical path, we are just going to calculate the duration of all possible paths. There's a large number of iterations, and it can be 100,000, 1 million. Of course, it is clear that with more powerful computers, we can have a better estimation, we can do more iterations, and the software can easily let you do 1 million iterations without too many problems. And today we can even have it on our PC or on our normal MacBook. Before it was a lot more expensive. Good Monte Carlo distributions and software is still expensive because of all the possibilities that you can do with it, but it can provide a very good result for your project. So we have also different random number generators that can be used. So when you look at the different possibilities, you have all those different possible calculations. And in the specialized software, you can define all of these things. Let's have a look at precedence diagramming method. Here we have the activities A to J. And what we have here, we have in fact different paths through the network. We have A, D, G, J. We have A, D, G, I. We have B, E, F, H, I. And we have C, F, H, and I. And what we're going to do, is for each of those activities, we have to understand what is their relationship between and the probabilities of those durations. And typically for every activity, we have a table like this. When we have a random number from 0 to 11, we will say that the duration is 6. This corresponds with the probability profile. So when we have a number between 98 and 100, it will be 14 and so on. Yes, there is a small error at the end, 94, 96, there should be 97, but okay, it's not a very big problem when we look at the software itself. The same thing for B, then we have the same for C, we have the same for activity D, we have the same for E, F, and all the activities. G is an activity where we don't have any variability, so whatever the number is, the duration will always be equal to 8. H, another distribution, I, and finally J is also an activity with a fixed duration. So this table is basically the overview. These are the probability profiles of all the activities. And what we're going to do is to generate random numbers, for example, 50. 50 for A, it will be 7. When we have 50 for B, it will be 8, and so on. We have a set of random numbers. For every activity, we have a different random number. We have for every iteration, we have a duration of all the paths. And basically, when I finish all of these things, I will have a lot of iterations. I have a lot of estimations of the duration of the project. So I can calculate the average and the standard deviation, and I can use that in a normal distribution. Let's have a look at some of the results. So we have results on 5,000 iterations. It is an Excel file, so it takes a little bit to open, but you can make it in special software, of course. We have an average in the first iteration that we did, the first 5,000 iterations, of 46 periods as a duration, and a standard deviation of 4 periods. When we look at the graph, the different graphs, we see the density or the mass curve in red and the cumulative curve in blue. So basically that's the overview what we have. We have the relationship between duration and probability. And we see here the frequency of duration. This is the result, the main result after the completion of the iteration. So we find this histogram with all the informations. Now in Excel, we can redo the calculation. When we push F9, the random table will be changed. And that's what we're going to have a look at in this new part. Here we're going to look at some different iterations. We recalculate the Monte Carlo distribution, we recalculate, we use new random variables, and you will see that with every iteration, we have a new result. What I did before, I calculated the different possibilities, I identified the different durations of the different activities, and I did about 5,000 iterations, which gives me this diagram. Now the thing is, we can have more iterations, which would be, of course, better. We can use different random generators. I just used the random generator built in Excel. There are other programs that can provide you different random generators. There is a lot of theory about that. Now what I see, this is one element, and the red line also, on the right hand side, you see the histogram, which is basically representing the same information as the density curve. The blue line is the cumulative curves, So we see basically an S-curve, which is typical for all these type of applications. And of course, for everyone, we have a different average, we have a different standard deviation, and we can calculate those. So the S-curve and those elements, we can use them later. But this is the real information from the Monte Carlo simulation that I did, a limited example. Now what we can do is to do a recalculation, and you see every time I press F9, the program recalculates. And every time when the program recalculates, we can see that there is a new value that will occur. So you see, every time I press F9, the calculation is done again because we get new random numbers that are given to the program, and we find all these different curves. Now we can do that, we can see what the elements are, and we could find the small differences. And when you look at it let's say when you look at it a little bit more in detail, you will see that the S-curve not always changes so much. But it's a good overview. Every time we have a new iteration, we find a new result, and we can do that with certain software. It can provide us more of those different steps, and you will see that when you do this, when you use the software, you may have different results. You will have better results when you have more iterations, and that's of course when you go to special applications. You can typically use like 100,000 times the calculation, 200,000 times 1 million. It depends on your application and the power of the computer that you are using. That's all I wanted to show you. And don't forget it, we're at the end of the video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and bye-bye.